we have the formation width. Take notes if you want to remember. I don't know how it is. It's a side width. That's something to do with where the sides. I can remember this is formation width. The formula should be used on B dot M, which is a size one. Right. Formation is like if you have a cut or even. So where would it start? If you understand the idea of formation, where we are forming the road, we are cutting it or we are embanking it. Are you okay? We are filling it or we are cutting it to go the road. So there's no point where we are just leaving the ground. Okay, this ground, leave it, just go and put the thing on it. Are you okay? Guys, you hear me? Just go and pour it there, okay? Every part of the existing ground will be cut off, literally. Are you okay? But the amount is where we are. So formation is going to do where the width of the actual road, the width of the actual what? I'm saying it for effect. Try it. So, is a width. The formation. When you see formation, is denoted with B. Is okay, right? So the B from here to here, W is half of the width from the actual sides of the road. Okay, so based on that, in the case where we have cut, okay, so which one of them, where do we find the formation width? A or B? Which one of them is the formation width? Oh, see it. B because like blah blah blah. Yes, flow. B because why B? Why is B a formation rate? Because that's where the what? I'm telling you to say myself. Your name again. Spell it. Which one? Why? A or B? Why would you find it? Because that's what the so what's the variable we use for formation? So D will be it. So D, that is what we have. So now you understand why now that when we take center thing of this now, so this should be but it's a reason. Formation with side formation. Okay, I spent time on this. Then we write the formula second. Exactly. B is always where we have a side. So here is not a side. This is into the soil. I have deep into the soil. So this is not a side. So we are looking for the find we always look for the side of the road. Where would you walk in? If finish the road, that's what it is. You're not walking the road. And I'm not getting. Okay, so I hope fellas come. Yeah, because you are not careful, you stop it. All right. Okay, so let's introduce H in the center line. So this is the center line. Okay. See all that. So this is the center line. And the center line is one of these fortune lines within design. That is just a systematic. Then you have the design. All right, so the depth at the center line or height of the embankment, okay, is actually what? H. That's it, we're done. What is the area of this cross section? a formula which we give it to the mathematicians who's doing their PhD to derive for us. So we have H into B and H. B plus MHH. That is the cross-section. So we are close to it. Okay, so when you get to the size, you need to get someone cross, just multiply with time, continue studying. It's okay. And then, but at least this one you won't get too long. Otherwise, we need to get a cross. Simple. Come on, thinking, is that all? Yes, that's cross section done. Okay, guys, calculate this for me. Just to wake you up quickly. Let's do this together. A certain station on embankment forming a level ground has a height at the center line 3.10 meters. A certain station. You see how the question is being put. So what is a station? At this juncture, one may ask, what's a station? Let's carry on. At a certain station, an embankment formed on the level ground. What is a station? All of you. Station. In surveying engineering, what is a station? Okay, it's like a place of known coordinates. Are you okay? Certain station, embankment formed on a level ground has a height at its center line of 3.10 meters. If the breadth of formation is 12.50 meters, so again, 50 meters. Find the sideways. Of course, the area of the cross section. Given that the side slope is 1 vertical to 2.5 horizontal. Okay, so simple formula, few values, calculate it and then give me the answer. Okay, let's look at this one quickly. 1 is to M. Someone will say it's so easy. What is 1 to 7? We are going to go through this. You can calculate it. Those who don't understand the slope. The question again. Okay. At a certain station, an embankment formed on level ground has a height at its center line of 3.10 meters. If the breadth of formation is 12.50 meters, find A, the sideways. Please, I'm going to take attendance after this. Remind me, please. Let's take it online and everywhere. Okay, so if the breadth of formation is 12.5 meters, find the sideways A and then B, the area of cross section. Given that the side slope is 1 vertical to 2.5 horizontal. Is that okay? Now let's be clear on the side slope. Is that okay? Side slope. Since the side slope, okay, in such a way that M units is horizontal projection for every single unit vertical rise. 1 is to M. Okay, it's actually M units, the horizontal projection for every single unit vertical rise. So one unit vertical rise results in M horizontal. When you see this, don't drop it. You're thinking 1 is a ratio for primary school. Look at it. So sometimes you can get it reversed. I think depending on whether British or Canadian, sometimes you stop. But I understand it in this context. Okay. This one is Bannister, it's British. It's okay. think you may do it in prices. So 1 unit H2. So that's rice, that's 1. Okay, rice. So how much rice? 1. How much rice? It's okay. Understand, don't joke with this, or I understand for your way. Do this. It's okay. So for once, we all come to understand these issues. When you see one issue, it's the same issue. Okay. Now let me tell you one thing about school. Notice that we know from previous saying that change is why change in rice or change in what? Isn't it? Okay. So we should be able to now see the relation to this type of slope. This way of equating slope. It doesn't have to be 1:2. But then maybe you can find a way to compensate and have this as a ratio of 1:2. And then you may know it. So don't try to interpret this like way to this slope. No. For any stream, why calls okay. Careful how you interpret. Okay, but that was just by the way. So now let's calculate the area based on the values. Give me the answer and let's move on. I think we know exactly what is what, isn't it? What is M? We know H. H is equal to 3.10 meters. B is equal to 12.40. M is equal to 2.5, isn't it? 1 vertical corresponds to 12.5. Wait, so what stops us? Someone said, here's what stops you from baptizing. What stops us from baptizing? Calculate it quickly. So that you get, I'm just being like, those are my friends. I want to see you calculate. Sometimes we calculate and we get wrong values. Last lecture, we have people calculating, getting different values. Calculate it so that no surprises. Then let's move on quickly. There are about 4 different ways of doing this kind of area calculation. So we're going to look at it quick, and we are out. Those online, you are not out, but we are taking attendance after this. If you are online and you've gone to bed, you may want to switch on your camera soon.
So yeah.
The H open brackets in the way the H is written. Calculate, let me compare to what I have here. 62.7 meters square. Okay, that's correct. So 62.78 meters square. Is that okay? That's good. Okay, what else are we supposed to calculate? We got the area. We're supposed to calculate the side waves. Calculate the side waves quickly. Side waves. Okay, the formula for sideways, isn't it? B over 2mh. So you don't have the formula, of course, you can't calculate it. Fellas, what do you have? Okay, 40 meters, that's correct. And so on. Let's take attendance. Those here, let's take attendance. Those online, type your name and index number on the WhatsApp page. Now, Grace, today, dear. Grace, type your name on the WhatsApp. If you're on WhatsApp, just put it there. Your name and your index number on WhatsApp. For me. Too many online. Where's my lady? What's your name, private? Achu. Achu. How's she doing? Have you heard? Yes, she's fine. She's alive. Attendance, those online, go on the page and type. Since you're not listening to me, none of you is typing. Those online.
You're listening to us.
Grace has done it. Okay, the other guy is sleeping. I hear people intentionally put some mannequin in front of the camera. They put some specs on it. He thinks a human being.
So we are here.
So we are here.
Not really. Okay, so after attendance is taken, we just move on to another case quickly. Like I said, today all calculations done. Finish now. So I need to move at a certain piece. Okay. That's not complicated, it's just a lot. That's all. Yes. Am I recording? Okay, yeah, that's good. Yes. It's very important to consider the dimensions. It's very important to write that you have meters squared. You need to cancel meters if some of the units if you need to cancel or convert if you need to convert. But most of the time I think with engineering, if you keep your units in meters, it should be just fine. Are you okay? Except if some small values, then in that case, really you should just find the meters. Yeah. Okay, so let's consider the case where we have what we call the cross fall. So the cross fall is where you have the slope, there's a slope, you are kind of side slopes slope at a certain slope of 1 to 2. And then you still have the actual side slopes 1 and 10. Okay, and then that's it. Basically, two slopes, one on the side slope. I have sort of cross. So now you have to factor the sloping into it. Is that okay? All right. Wait, so we have H, we have B, give a 2. Center line like so. Right. Where is the B? Is it happy or dying? My money is better.
No.
I like that. I want to check it out. So you are 2. So W here we have 2 W's. So we don't have the same W. We have W1, W2. W1 here by the convention, really convention. So this side 1, 2. So W1 is not equal to W2. As in the first case, we had a level 1, but here we have different. So we have now changes the root of the symmetry. And H will be somewhere up to. Okay, and we are good to go. Yeah, we can also have that. This one is for the cutting, and then we can have the embankments. Where we have the embankments, similar thing is done. So here we have that. So slope goes this way. So the slope here, there's a certain slope. Going away. There's a constant slope of 1 is to k, but then we have our normal space 1 is to k. So these are two different things. Obviously, we drop down our CL here, and E on 2, yes, W will be different now. So note how here we have just W1. So here, you see, if you look at the derivation, you understand why we have W1 here. And now we have W2. You can see that one. This is looking at 1 is to k. Yes, H will be 2. If we actually project on the side, we get H. So this stands for this. So we reference H to this line. Projection of the center line. Okay. And then we can write formula, simple as that. Not complicated. B on 2, W1, W2. That's the one in M embankments, one in K size. So this is called a cross form. Cross form. Okay, so let me just carry my laptop. So like, look at my face. I know you miss me. So W1 is equal to B on 2 plus MH K minus M. W2 is equal to B on 2 MH K over K plus M. The good thing is that we know what these K, M, and H and all that are. Are you okay? All right. So we've been able to determine our side waves 1 and 2. Okay. And then so what's the next thing we need to Christ? What's the next thing we need to be interested in? Exactly. We need to know the area, which we are going to write down. The area is a very complicated one. 2M B on 2 plus MH W1 plus W2. So if this comes in exam, would you say I'm a wicked man? You have to recollect this formula. But it's not even the most complicated formula I've seen. Anyway, yeah? You agree? Anybody that says that he agrees, the rest of the class will go like, bad boy. You're not a nice guy. Anyway, so 2M. Okay? This is the area. All right. Set. Done. Now, I'm not going to ask you to derive it. All you need to do is remember it and then use it. Okay, so calculate the side weights. Question. Calculate the side waves. And cross-sectional area, CA of an embankment. Okay, let's hold on, let me just Take it. Cut. Okay. Formation width. .50 meters. Side slopes. One vertical to 2 horizontal. Okay, center line. Is 3.10 meters. And there's a cross fall of 1 in 12 at right angles to center line. Center line of embankment. Okay. I know the handwriting is the best, so you can see everything. Okay, but we can just pick out, isn't it? Calculate the side widths. We have the formula, isn't it? Side widths, isn't it? Right. And then, what is this one? What did I say C is? What did I say C is? Cross-sectional area. Are you okay? Cross-sectional area, embankment. Now what again? So what do we have? What don't we have? Formation width. We have it. What else? Side slope. What is side slope? 1 vertical to 2 horizontal. Is 1:m, isn't it? So m is equal to 2. H is equal to 3.010. All right. So we have, what about B? B is equal to 12.57 meters. So this doesn't have a unit slope. Put it in your mind. This doesn't have any units. Okay. And then we calculate it. It's okay. All right. Now take note that this formula, I think that's something I didn't state. This formula, depending on whether you are cutting or embanking, it changes slightly. Is that okay? So take note of that. All right. So let's move on. I think we can calculate it. Do you want to calculate it? Do you want to do the calculation? Or we should just move on? You can do it at home, isn't it? Yeah, it's not complicated. Please do it at home for us. And basically, that's the next one is where you have sections, parts in cut and parts in fill. Okay. So you do this is actually that you don't have, this one is fill, this is a cut. But in this case, you have something looking more like, I'm going upwards this way. I'll do some embankments here. Are you okay? Then I'll need to cut this part. Okay. Then I slope up. So these are side slopes. Are you okay? These slopes are not the same. Okay, so this one is 1:m. This one is 1:n. Okay, this another scenario. And then we have, of course, your b/2. See a b/2 is there. Which one is the fill, A or B? Of course, it's A, isn't it? Fellas, do you see it as that? Do you see why A is a fill, B is a cut? Okay, so this is looking more like a cross fall, but we don't have a complete fill or cut in. A little bit of. So this is the design. Look at the design. This is the design. The design goes in the okay, so you have to fill here, cut here. Do you get it? This will happen at certain places. Look at it well. At some places, you may want to fill some part and then cut into some part. Do you agree? Look at how the landscape looks like. At certain parts, you may have to just, I'm looking at places like the Crappy Mountain. Be very complex, isn't it? You just want to have a fill, but it's not working because the mountains are funny. Are you with me? So you have to fill here, okay? Then you have to cut here. Then what's your road? Your road is this part. So the cars will be traveling like this. There'll be a car here. Standard car here, maybe 2 lane. Are you okay? But this place is filled. This was cut. Are you okay? But generally, we have a sloping surface. I don't know, topology in terms of the cross section. This place is actually sloping. I'd say 1 in K, like the cross fall. So a question, I can ask you a silly question in exam that why do you want to have such a situation like this, scenario like this, where you're cutting and filling at the same time, but then you cannot sometimes to have a situation where you have the cross fall situation. Are you okay? The cross fall, we don't have this scenario. This is the one we started with. It's symmetrical, the ground is just flat. We don't have any slope at all. So we don't introduce 1:K. But really we turn it like that and we start having this scenario. Like so. They have 1:K, we have 1:M. Are you okay? That's why we started using these formulas. Are you okay? Cross fall. Okay. So do you get this one now? That it's possible to have this. Do you get it that you can have this? Who's been to Kumasi before? Hands up. Who's been to Kumasi? You don't want to raise up here. Who's ever been to Kumasi before? You see, so in Kumasi, if you are given a practical to do as a student, you can't lie. The topology is like that. If you lie, your answer will not, then everything will not work. The whole thing will not start because it's just like this place. But even this place, see, if we just slope down, Kumasi is like we sloped here, we just went down here. Are you okay? So if you're an engineer, you got to know what you're about. The textbook will not work, and that's the kind of situation we are having here, or the different scenarios that we are having. Are you okay? The sad thing for the student is that you need to know which formula works for which one of them. Okay. You start with the basic. Do you still remember the first formula? A equal to what? The very first formula for calculating area, cross section. A simple one. Area A equal to 8R A plus F. Right? Then move to this one, isn't it? We are doing cut and fill. So yes, a fill. Yes, a cut. So because I see the ground level is so I want to keep cut here. I agree. But here, what do we have to do? Try to fill this place. All right, and make sure your size groups are 1:10. That's all. Okay. And there's a formula for that. Calculate W1, W2. Okay, so with this one, you have area of cuts, you have area of formula for it. All right, so what's the point of even writing it? Let me just write it for you to see. The only way to become familiar with it is to sit down as a class 2 or 3 of you and to discuss it and to just go through it over and over. That's the only way. So area of fill is given by half B over 2. They become familiar with the formula. Squared all over K minus M. Area of cut half. Some of the formulas too, they look alike. So that's a way of just remembering. So this one is the same formula, B over 2, just the minus makes the cut. I get that. Squared over K minus N. So the N, this slope N, you see that? So N for cut, the cut side, M for the fill side. Okay, the subtraction remains constant, but now you have plus here, minus for the cuts. So if you want to remember it, you can kind of easily remember. But when when a lecturer talks like this, remembering, the student starts thinking, it means he's going to ask a question on it, which may not be true. Okay, but I'm just saying that if you really wanted to, the formulas are not written with memory, not without memory. The author, the person who comes up with this, okay, I need to write the. So let's take a look at that. Okay, so let's do this. This is the last calculation on area. Okay, then I'll just touch on the volume. I've already touched on it. Okay, we started with the mean areas. Can have areas, volumes by other methods. Okay, we look at the end areas, mean areas. Okay, please more that formula, and then let's round up. Is that okay? The next thing we do won't be calculation based. I just feel it's enough. All right, so let's do this one. A road has a formation with, so as I say it, write just the part that's important. Don't write the story. A road has a formation width of 9.5 meters. What should you be writing? A road has a formation width of, so that's B, isn't it? Okay. And side slopes of 1 vertical to 1 horizontal. What's that? In cut. 1 vertical to 1 horizontal in cut. What's that? So we are dealing with cut and fill. N. So N is equal to 1. Okay. And 1 vertical to 3 horizontal in fill. What's that? M is equal to 3. Right. The original ground had a cross fall of 1 vertical to 5 horizontal. That's what? K equals to 5. If the depth of excavation, online people are there. Okay, 1 minute. We come back for the last time, those online. If the depth of excavation at the center line is 0.5 meters, what's that? If the depth of excavation at the center line is 0.5 meters, what's that? H, isn't it? H equals to 0.5. Calculate the side widths and the areas of cut and fill. So the side width formulas, I need to give them to you. Okay, so there is, after we connect to the WhatsApp, we'll answer this question. That's the formula on the screen, those online. So let me write it up whilst we reconnect on the WhatsApp and Zoom. So W1 for cut and fill is equal to, I've intuited, B on